buyer for a shoe store learns that the average woman's shoe size is an 8. Now, the buyer decides to stock size 8 shoes almost exclusively. Which of the following conditions would best support this decision? Now, the scenario is that the buyer identifies the average woman's shoe size as 8, and then he decides to stock it almost exclusively. Now, which condition supports this gamble? Now, here is the framework of our problem. Now, our data input tells us the mean is size 8. Now, this is just the central balancing point of all the values. But when the buyer makes the stocking decision to buy only size 8, they're making a massive assumption. Now, they're assuming that because size 8 is the average, it must also be the most popular size on the shelf. Now, in the real world, that assumption can cost you thousands of dollars if you do not look at other metrics. So, to solve this, let's do a quick refresher of some key terms. First, the mean. You calculate this by adding up all the shoe sizes sold and then dividing by the number of customers. Now, the median, if you lined up every single customer from the smallest feet to the largest feet, the median is the person standing in the center or in the middle. And third, the mode is this is the value that appears most frequently in your data set. Now, in retail terms, the mode is the absolute best seller. Now look at this visualization. If we want our stocking decision to be successful, we need the size 8 to represent the peak demand. If the mode is equal to the mean, it guarantees that our mathematical average size 8 is almost the exact size in the highest demand. So it bridges the gap between a pure calculation and actual human behavior. Now, let's face it, stocking only one size is extremely risky. Now, it only works if customer demand is tightly clustered right around that center point. Now, if the mode, which is the size most frequently requested by real people walking through your door, is also an 8, then your inventory strategy perfectly aligns with the largest segment of the market. What about other choices? Why doesn't a large range help us at this point? Well, if the range is massive, it means you have customers with tiny feet and customers with very large feet. So if you only stock size 8, you are going to alienate a massive portion of your market. Now, to stock efficiently, you have to know your curve is normal and tightly packed, or if it has multiple different peaks of demand. So let's evaluate our options. Option A large range, weakens the decision because it means you need more variety, not less. Option B, the median is less than 8, weakens it because it tells us over 50% of your customers actually need smaller sizes. Now, option D, mean is equal to median. Um, Now, this just tells us the data is symmetrical. It doesn't tell us if size 8 is highly popular or just a midpoint between two extreme custom sizes. Now that leaves option B, mode is equal to the mean, which strongly strengthens our case by confirming that size 8 is the top seller. So the mean tells you where the math center is, but the mode tells you what people are actually buying. Now, without knowing the mode, a mean is just a number. So condition B provides the crucial missing link by guaranteeing your average is your peak seller. There you go. The condition that best supports the buyer's gamble is B. The mode of shoe size is equal to the mean.